Hi, my name is Allison Arnold. I am the Agriculture Extension Agent with the Cooperative Extension Service here in Buncombe County, and I'll be your host today. We'll make time throughout the program for questions and invite you to put your questions in the chat box. And I've put the corrected link to the handout in the chat box, but I'll do it again here once we get started because I know people continue to join us. I want to welcome you to Gardening in the Mountains, Understanding Natural and Organic Pesticides. Our speaker today is Phil Roudebush. Phil has gardened for many years in Mississippi, Kansas, and here in Buncombe County. He is a retired veterinarian and researcher and a Buncombe County Master Gardener volunteer and a dedicated garden teacher. Phil has battled many blights and bugs over the years and has learned that natural pesticides can be a confusing and complex topic. And so today is going to help us understand how to choose and use natural and organic pesticides in your home, garden, and landscape. Please welcome our own Master Gardener, Phil Roudebush. Take it away, Phil.
Mike, I need help turning up these speakers.
So welcome everyone, and thanks for the introduction, Allison. We're at that point in the growing season when we're already having problems with pests, or we're anticipating that pests will become an issue in the weeks and months ahead. So it's a really good time to think about how to manage these pests. And today we're going to focus on how natural and organic products might work for you. As Allison mentioned, there are notes that go along with this presentation, and if you're able to access those or print those off, they'll be very helpful. We're pretty much going to go through them in chronological order here, so would encourage you to get access to those notes, and they have most of the details and beyond of what we're going to cover today. Also want to say that at the top of the handout, there are a list of additional resources. We'll be mentioning these again as we go through the presentation. For those of us in North Carolina, the Extension Gardener Handbook and the North Carolina Agricultural Chemicals Manual are excellent resources. We'll mention those again. We'll talk more about OMRI and their Clemson and Washington State Cooperative Extension Services also have some excellent materials. We'll talk about those as we go along. And obviously, if you're using a commercial product, taking the time to read the label before you use the product can also be very beneficial. So these resources are listed in the handout, and we'll mention them again as we go along. For those of us in North Carolina, there was a recent publication. This just came out in April of this year, and it's a homeowner's guide to managing diseases. You can find it by searching on North Carolina Extension AG 896, and it has a list of active ingredients, commercial products where those active ingredients are found, and their label usage for herbaceous ornamentals, woody ornamentals, lawns, fruit trees, small fruits like strawberries and blueberries and blackberries, and vegetables. And so this would be an excellent handout to go ahead and print out and use in conjunction with the other notes from today's presentation. Also put in a disclaimer here. You're going to see lots of pictures of products, and brand names and pictures of products appearing in the presentation are for product identification or educational purposes only. No endorsement is intended, nor is criticism implied of similar products not mentioned. So we've made the lawyers happy. So by definition, a pest is any unwanted living organism that you might find in your home, garden, or landscape. And it really runs the range from microscopic organisms all the way to larger animals, such as nuisance wildlife. We're not really going to focus on wildlife today, but we're primarily going to be talking about those pesticides that can be used against weeds. We call those herbicides. Against insects, we call them insecticides, and insects, of course, are six-legged critters. And then against the eight-legged critters, such as mites or ticks, we can call those miticides or acaricides. And then fungicides against fungi and bactericides against bacteria. And those are the ones that we're going to focus on today. So here's the outline where we're going to go. I want to talk briefly about integrated pest management and also then the regulation of pesticides. I think it's important for you to understand that background. And then we'll go ahead and talk about 5 different categories of natural and organic pesticides: soaps and oils, botanicals, then minerals, microbial pesticides, and then a few that kind of fall under the miscellaneous category. And after each of these sections, I've got a question slide. We'll pause, and if you have a question, you can go ahead and submit it in the chat box. Allison will go ahead and then share that with everybody, and I'll attempt to answer those questions. We probably won't have time today to talk about pesticides failures and phytotoxicity, but I'll give you a reference that has some good information about that. So here we go. So I like to think about integrated pest management, again, whether we're talking about a microscopic pest or whether we're talking about nuisance wildlife, to really think about it as a pyramid. And what we would like to do is really focus our efforts at the bottom of the pyramid. Think about preventive or cultural techniques that we can use, which are more benign. And as we move up the pyramid, our intervention increases, but it also becomes more toxic, not only to the environment, but to the plant itself. So we're going to be focusing today on the top of the pyramid, about natural and organic compounds or chemicals that can be used, some biological methods, but always keep that in perspective with an overall integrated pest management approach. And the number one thing is we really want to identify the specific pests that we're trying to address and use management techniques that are directed to the pest of concern rather than relying on just a broad spectrum chemical approach. So that's, even though we're going to be talking about chemicals and biological approach, we really want to put that in perspective of the overall management strategy that we're using. So what about regulation of pesticides? And I think that's an important place to begin. And I always use the terminology that pesticide users beware. We certainly need to be aware of the potential toxicity of pesticides, whether they're natural, organic, or synthetic. But I also use that term because it's important to understand that pesticides in the United States, at least, are regulated by the Environmental Protection Agency. And of course, as their name implies, the EPA is primarily focused on environmental and human safety concerns. And so efficacy data are not required by EPA for pesticide regulation. So let me say that again. Efficacy data are not required by EPA for pesticide regulation. And so they really depend on product manufacturers to supply objective and accurate information regarding the effectiveness of their products. So just because a product is registered by EPA doesn't necessarily mean that there is a lot of efficacy data to support claims that are made by that commercial product. So where can you look for some additional information? Well, at least in North Carolina, we have the North Carolina Agricultural Chemicals Manual. It's published each year. It's available online. If you can just go to the Cooperative Extension Service website and search on the chemical manual, and it's available electronically. And it has a whole specific information about products used in North Carolina for insect control, disease control, chemical weed control, fertilizers, and much more. And as Extension Master Gardener volunteers, we really rely on this North Carolina Chemical Manual as one of our primary resources. The other thing is to kind of think about the term organic and organic gardening. The Organic Foods Production Act was passed in 1990, so that was almost 30 years ago, but it took almost 10 years for the final rules to be published by USDA. So the final rules have been out there for about 20 years. But there was really a need to look at the wide variety of products that were on the market and try to establish which of those met the USDA organic guidelines. And so OMRI was created. It's the Organic Materials Review Institute. It is a nonprofit organization that was established in 1997 to really look at the Organic Foods Production Act and all the rules that were coming from USDA, and to certify both organic products and organic processes. So, and you will see a company that has submitted their product to OMRI, and it has passed their inspection will appear on their list, and they can use that logo on their product. But there are a couple of things to understand about the OMRI list, and you can find the list by, again, just going online. One is, again, similar to EPA, they do not require any efficacy data. So all they're saying is by appearing on the list that this product or process meets the USDA guidelines. Secondly, it's a voluntary program. So you can have two manufacturers with identical products, with identical active ingredients. One of them will go ahead and voluntarily submit their product with a fee to OMRI. It gets listed and they're able to put that logo on their product. But that doesn't necessarily mean that their product is better than an identical product that wasn't submitted. So again, a couple of watch outs for that, and you are welcome to go out and look at the OMRI site and look at the list they have. The other important concept about organic is sometimes it becomes a very confusing term because it's used differently depending on who is using the term. And as an example, my father was a research chemist for his entire career. And if you ask him what organic was, he would tell you that organic chemistry is the branch of chemistry that studies the structure, the properties, and the reactions of compounds that contain carbon. So basically, we are a carbon-based living organisms here on Earth, and it's the branch of chemistry that basically studies carbon. Carbon is the king or queen. On the other hand, if you talk to USDA, you talk to OMRI, if you talk to gardeners or farmers or other regulatory entities, organic is a term that's used as a production method. So it has nothing to do with carbon. And that's where it can become very confusing. And so you will find products in the marketplace that may be OMRI listed, are certainly approved, are natural and organic products that don't contain carbon. And so when you use the term organic, just be sure to identify whether you're talking about it from a chemistry standpoint or whether you're talking about it from a production method standpoint. The other important thing is to remember is that just because something is certified as organic or appears on an OMRI list or some other list doesn't necessarily mean that it's non-toxic. And that goes for natural products too. And what I find is most people say, well, this is organic and natural, so it must be completely safe. And that certainly isn't the case. And so products that are OMRI listed or that are talked about as organic or natural may be very toxic to both the environment and to plants and to us. An example I given for natural, and again, natural is a completely unregulated term, so we can really apply that, or people will apply that to a wide range of processes and products. As I always ask people, lead, arsenic, the current coronavirus, and plutonium are all natural, but that doesn't mean that we want to be exposed to those in high levels. So don't equate organic and natural with certainly non-toxic. And here's an example from the marketplace. This is from a major manufacturer of pesticides, and they have a complete line of pesticides called Garden Naturals, but they are very upfront and honest about it, and they always asterisk that and say that Garden Naturals are not intended to imply environmental safety either alone or compared to other products. And finally, for commercial products, read the label. Those products that are regulated and registered by EPA will always have quite a bit of information associated with the label. And again, and point you to the Extension Gardener Handbook. Appendix B has excellent information about pesticides and pesticide safety. And we've all gotten used to the term over the last couple of years of PPE, personal protective equipment. And again, I'll just say use appropriate PPE, and that will be listed in commercial products in the information they provide. So we provided some definitions and kind of an overview of kind of the regulation of pesticides. Let me pause here, and if you have a question, please put it in the chat box.
Phil, I don't see any questions at the moment. I've been putting links to the various sites that you've been describing. I've put those into the chat box, but I don't see any questions at the moment.
All right,
Oh,
so let's move on. We're going to talk.
Yep,
Pardon?
I'm sorry.
Yep.
Someone did ask, where do we find efficacy data?
That's a good question. Efficacy data is probably would start with the Extension Service and Extension Service publications. Their primary role is to take the scientific and research-based information and put it into a format that can be used by the public. And then I would go to websites of particular companies and their products, and oftentimes they will have scientific information or efficacy data on the website, and those are probably the two places I would start with.
We have one more, and if you have outdoor indoor pets, is it better to use natural materials as opposed to the front line for fleas and ticks?
That's a pretty complicated question, and I don't think I'm going to get into that today. Specifically, that's probably an hour talk in itself is flea control. So I don't think I'm going to go there today.
So, okay, one more. Some labels list 90% or so other ingredients. What does that mean? Is it any way to tell what those ingredients are?
There's no way that I know of to tell what those ingredients are without contacting the manufacturer or looking at the information they have on their website.
No. Okay, thank you very much.
So we're going to talk about, first of all, about soaps and oils, and we'll talk about insecticidal soaps. Insecticide, or the general description of a soap is the soap is a salt of a fatty acid. Fatty acid is an organic compound, so it's basically made up of chains of carbon molecules. And the longer that chain, and the one that's pictured here shows you there's 16 carbon molecules that are attached to a sodium. The longer that chain of fatty acid, or longer the chain of carbon molecules, the more effective it is as an insecticidal. It's important to remember that insecticidal soaps must contact the pest directly. So it's not going to be beneficial to spray it on the plant, have it dry, and then have the insect or other pests arrive later. The mode of action of soaps is actually pretty poorly understood. It may go ahead and disrupt some of the cell membranes. It may act as a growth regulator. It may block the spiracles, which are the breathing pores of the insect, but it's really poorly understood in most cases how they work. We do know that they are more effective as an insecticide against young or soft-bodied insect life stages. There are commercially available insecticidal soaps. These are generally potassium salts of long-chain fatty acids. It's also been recommended by some people to use household soaps. And in that case, you would want to use just a dishwashing detergent, not a laundry detergent, or not something you'd use in a dishwasher itself. So we're going to go on and talk about the minerals, and probably the first one we'll talk about is elemental sulfur, often called garden sulfur. It's probably one of the oldest fungicides and pesticides. If you live in an area that has alkaline soils, soil sulfur can be used to lower the soil pH. It's basically metabolized by the plant into hydrosulfuric or sulfuric acid, and that is how it works. It's an effective against a wide range of fungi, but only on the plant surface, and really doesn't do much once fungi have become established in plant tissue. And it may have some activity against mites and ticks. I can remember as a child taking garden sulfur and dusting my socks to try to keep and dust it on my pants, so it has some activity there. And it probably should be avoided in hot, dry weather. A product that isn't really natural and organic, but is very similar, is called lime sulfur. And this is sulfur that's been added to calcium hydroxide. It controls fungi, bacteria, and insects on tree bark, but will burn actively growing tissue, so it only should be used in the dormant phase. I've used lime sulfur as a veterinarian oftentimes in the past for topical ringworm therapy. It's very safe on kittens and puppies. And so we would use it for topical therapy for ringworm, but it does have a very offensive odor. It's basically very strong rotten egg odor, either on an animal or certainly on plants. Copper, along with sulfur, is one of those that has been used for a long period of time. It denatures proteins and will kill pathogens on the plant surface, and is not effective for pathogens in plant tissue. And that's kind of a general thing to think about with many of the natural and organic compounds. And so similar to sulfur, it's primarily going to be used for surface pathogens. We want to use what are called fixed copper fungicides. And probably the first fixed copper fungicide that was used over 100 years ago is called Bordeaux mixture. You can still find this and purchase it. And it's copper sulfate that has been fixed with hydrated lime. It was originally used for fungal diseases that attacked the vineyards in Bordeaux in France. And there are a number of other so-called fixed coppers products that are listed here: copper oxide, copper hydroxide, copper fatty acids or copper soaps, and copper diacetate. These are examples of 3 copper products that you can find readily. They have a different percentage of copper in them. One's a fixed copper sulfate, copper soap, and copper diacetate. And in general, the higher percentage of copper is more effective. You basically spray this on the plant, and then every time that the plant gets wet, either from watering or from rain, some of that copper is released. But similar to sulfur and many of the other products, is what we call a protectant fungicide and bactericide. In other words, it's not going to be effective after the disease has already established itself in the plant. So here's a picture of a leaf from a tomato plant that has early blight, and a tomato that has fruit itself that has bacterial spot. Once the organisms have become established in the tissue, once you see signs of the disease, a product like sulfur or copper is not going to be effective. So you're going to want to think of it as a preventive treatment. And so the recommendation is apply every 3 to 10 days when the disease threatens. So an example would be now, if you've had problems with early blight in the past and you want to try to prevent that, you would want to start with copper or sulfur or that type of treatment before you see the disease problem. Epsom salts are just magnesium sulfate. They're a very soluble form of magnesium and sulfur that can be either used as a foliar spray or as a soil additive, specifically if you know you have a magnesium or sulfur deficiency. But there are also lots of testimonials and myths about its use, primarily as a foliar spray, to prevent all kinds of pests. And most of those myths are definitely that. They are myths and not accurate. And so if you've used Epsom salts or you're interested in that, I would lead you to this reference. It's listed in the additional resources. Linda Chalker Smith in the Washington State Extension has an extensive website on horticultural and gardening myths, and she has a specific article on Epsom salts, miracle, myth, or marketing, and I would encourage you to read her article if you want to use Epsom salts. Kaolin Clay is, again, a mineral product that can be diluted in water. Kind of the traditional recipe is 1 quart of clay in 2 gallons of water, and usually add some liquid soap to help emulsify and to keep it in suspension. You then spray it on the either on the fruit or on the plant, and that kind of creates a barrier film. It's probably best against preventing insect and fungal foliar diseases. Again, is not going to be efficacious once insects or fungi have entered the plant tissue, and it can be used especially on fruit to protect against sun damage. Iron is an essential nutrient for plants, but in high levels, it can be absorbed into plant tissue and will cause what's called iron oxidation injury and death of the tissue. And there are a couple of different iron products that are available. One is iron that is chelated with what is called HEDTA, and chelation with HEDTA helps keep the iron soluble in water, and it also increases iron uptake by the target plant and leads to its death. And iron HEDTA is marketed for broadleaf weed control in lawn turf and also hard surface cracks. And it's been tested on especially cool weather grasses such as fescue and ryegrass and bluegrass, and really has very little toxicity against those, so it can be used for dandelion or other broadleaf control in grasses. But the warm weather grasses such as Bermuda grass and zoysia, there's really less work been done on whether these iron products are safe or not. There's also iron sulfate product that's made for control of moss. And again, these have no residual effect, but just are absorbed directly into the plant and cause immediate injury. Boric acid, I was familiar with borax growing up in the 1960s. So one of my favorite TV shows was Death Valley Days, and 20 Mule Team Borax was the laundry booster that was the sponsor of that television program. So I knew about borax early on. Borax is just a mined product that's sodium borate. Boric acid is also available, and it's basically refined from borax. Both of these are insect stomach poisons. They may also have some ability to control weeds and mold, but they can be toxic to plants. So they probably shouldn't be used directly around plants. Bicarbonate, sodium bicarbonate is available as baking soda, and there's also what I call garden bicarbonate, which is usually potassium bicarbonate, which is found in garden products. And it's fungistatic. It creates an alkaline environment on the surface of fruit or on plant tissues that are hostile to fungal growth. It's been most commonly used for post-harvest fruit. So after you've harvested the fruit and you're storing it, and you're trying to prevent fungal infection on the outside to occur, that's primarily where it's been used, and it can be toxic to plants at very high concentrations. So if you're going to use bicarbonate, certainly using a potassium bicarbonate, a specific garden product, and following the directions is probably the best approach. Diatomaceous earth are just the fossilized remains of microscopic diatoms. They have a very high silica content. And if you use diatomaceous earth, you want to use what's called food grade quality, which is primarily what is sold in horticultural or garden centers. And it's basically an irritant and a desiccant. And what you do is basically dust it around the plant. You can actually put it directly on the leaves, and it will irritate and prevent snails and slugs from attacking the plant, and will cause desiccation of some insects as well. And the final mineral we'll talk about is silica gel. Silica gel, we're all familiar with those, of these little packets that oftentimes we'll find in other commercial products that are used to keep the humidity low. It's a desiccant dust, is effective against insects, mites, and spiders, and you'll often find the silica gel combined with the natural pyrethrums that we talked about earlier. So those are the mineral pesticides. So let's stop for a moment and see if you have questions about those.
Well, Phil, we've had a couple of things going on in the chat box. I've been working with that because reiterating the importance of looking at the label for mixing ratio and storage of product. I've sent out Linda Chalker-Scott's website and a couple of links because she's actually addressing things like using compost tea for protection and Epsom salts and baking soda. And so I've been sharing some of that. One question about copper: do you need to cover the entire tomato plant with copper? Do you need to have a thorough spray of that?
That's a good question. And certainly one of the biggest problems with pesticide failures is the lack of adequate coverage, especially on the underneath side of leaves. So yes, the entire plant, especially on leaves, both the upper and lower surface need to be covered.
Okay, great. We have one question on herbicides for poison ivy, and I'm sure you'll get to that.
Yep, we'll talk about at least one that is a natural organic option besides the obvious synthetic options like glyphosate.
Okay, two more quickly. Ortho sells a sulfur product for slugs and snails. Do you have a comment about that?
No, the original product for slugs and snails was highly toxic to children and animals, and most of those have been removed from the marketplace. So an iron product is the most common product that's available now that I'm familiar with. So I'm not familiar with a specific sulfur product, but certainly an appropriate concentration that might be effective.
And is there a kaolin? Can you find that at garden centers?
That's a good question. I have not found that in garden centers, but certainly it might be available. But that's a good question. I have not seen it specifically.
Okay. Okay, thank you. I think we're good.
All right. So the last big category we'll talk about are so-called biopesticides, where we're using one living organism or a living organism extract to control another living organism. So we can have bacteria controlling fungi, fungi controlling insects, bacteria controlling insects, bacteria controlling larval stages like grubs and caterpillars. We're not going to not have time to cover all the biopesticides, but kind of give you a few examples that you can find. Bacillus is a large group of bacteria that are commonly found in soil and water. They are very effective biopesticides. They can be used as a drench to help control soil fungal pathogens. They can be used as a spray for foliar pathogens. But again, similar to what we talked about with copper and sulfur, they need to be used before signs of disease. The cease product is Bacillus subtilis. It's primarily used by commercial horticulture entities. It's almost $100 for that large container and probably isn't something the home gardener is going to use. But the product at the bottom, amyloliquofacians, is available in smaller quantities and is reasonably cost-effective to use. Probably the most common bacillus that's used by the home gardener is called BT, Bacillus thuringiensis. It's also a soil-dwelling bacteria. It's basically consumed by the larva or the caterpillar of the insect. It's a stomach poison. And the important things to remember about BT is there are different strains that are effective against different kinds of insect larvae. So again, very important to read the label. Make sure that the specific BT product that you're using has specific activity against the insect larva that you're concerned about. It does break down in sunlight. So again, using it on a cloudy day or using it in the evening might be the best strategy, and it can affect beneficial insects as well. This is a bacteria, Streptomyces lydicus. It's a soil bacterium just like the bacillus. Produces many antimicrobial compounds, and so it's usually used as a soil drench and or can be used as a soil drench or a spray, and it colonizes both the roots and the leaves, so you can treat the soil or foliar diseases. Part of the problem is, again, finding it in small enough quantities that the home gardener would use. The product I'm most familiar with is actinovate, but this will treat over 200 plants, and most of us are usually dealing with smaller numbers of plants. Spinosad, again, I'm familiar with it as a veterinarian. It was originally marketed as an oral product to control fleas. It's shown here. It's a soil-dwelling actinomycete type of bacteria. Again, it is a bioinsecticide and can affect the insect either by ingestion or contact. You'll most commonly find those in ant baits, but there are also some garden insect sprays that contain spinosad. Milky Spore is a soil-dwelling bacteria that is specifically used to control grubs of the Japanese beetle. It may have some activity against other grubs as well. Basically, the grubs will ingest the spores that will go ahead and grow inside the grub. They'll die within one to 3 weeks, and then when they die, more of those spores are released into the soil. And finally, Allison mentioned already compost tea. Similar to Epsom salts, compost tea is thought to have lots of miraculous uses in the garden, which may or may not be the case. And the benefits of compost and compost teas are really difficult to document because there's a huge variation in compost ingredients, processes, and the final composition. And so certainly they might be beneficial, but there's also a lot of myths around their use, their purported use, and again would point you to this article by Linda Chalker-Scott about compost teas if you want to use those. And finally, just to show you that not all viruses are bad, like our current coronavirus. If you're a fruit grower, you know one of the biggest problems in apples and pears and some other fruit are the codling moth larva. And there's actually a virus that's an invertebrate virus, so it doesn't affect mammals or you and me. It only specifically affects insects. And this is insecticidal for codling moth larvae. And probably most of us aren't going to use that, but certainly commercial fruit growers do. And just to show that not all viruses are necessarily bad. So let's pause here and see if you have any questions about microbial pesticides. There are several others we didn't mention that are listed in the notes. Oftentimes they're too expensive for most of us to use as home gardeners, but I think it's important to realize that there are a variety of products that you might find beneficial. So stop here and see if there's questions.
Thank you, Phil. Once again, I've been answering a few in the chat box. One, what product have you had the best success with in controlling tomato blight?
Depends on if you're talking early blight or late blight. Late blight can really be tough unless you use a very aggressive preventive spraying. The best thing I think for tomato blight is to unfortunately go away from heirloom varieties and go toward hybrids that have inherent resistance to both early and late blight in their genome. So the only problem with that is you really don't know the specific fatty acids that are in the household soaps. They're primarily formulated to cut grease, not kill insects. But if you do use that, generally recommended to use a 1 to 2% solution, and that's somewhere between 2.5 and 5 tablespoons in a gallon of water that can be sprayed. A couple of watch outs with using soaps as an insecticide. They were more likely to cause damage to the plant if they're used on a very hot sunny day. So if you use them, probably using them on a cloudy day or using them in the morning or afternoon. There are also some plants that are exquisitely sensitive to soaps, and one is pictured here, lantana. And Clemson has an excellent handout, HGIC 2771, if you just search on that, and it has a list of those plants that are very sensitive to insecticidal soaps, whether they're commercial or household, and would recommend that you look at that before you use an insecticidal soap. And also remember that they can be harmful to beneficial insects. Horticultural oils are a little bit hard to understand, so I want to spend a couple of minutes going through those. Most of these are either petroleum based, and they'll list the ingredient as mineral oil. We're starting to see more and more plant-based horticultural oils. They have a wide efficacy against a variety of insects and mites, and occasionally are some times that it can be used for fungal pathogens as well. But it's very important to read the label carefully when using horticultural oils. The label will list the suitable plants and also the susceptible pests. So it's important to identify specifically what pests you're trying to treat and on which plant, and be sure that that is listed on the label. Now, in the past, the horticultural oils kind of fell into two broad categories. One were called dormant oils, and as the name implies, these were to be used in plants primarily, usually in the wintertime when they're in the dormant stage. They are mineral oils that are very high in weight. They're more viscous, and thus they're less likely to evaporate after they've been sprayed on the plant, which may make them more effective, but they're also much less safe for plants. And they have a low what's called UR, which are unsulfonated residues, and sulfur residues in petroleum products like mineral oil can be very toxic to plants. And so dormant oils have pretty much been eliminated from the over-the-counter market. If there are any available today, it's primarily for commercial use. Summer oils are also mineral oil, but they've been more highly processed. They're lighter weight, they're less viscous. That means they evaporate more quickly, which means they may be a little bit less effective, but they're much safer from plants because they have a high UR, meaning they have very little sulfur residues in the oil, and so they're much less likely to cause toxicity to the plant itself. And oftentimes these are called superior oils. For today's market, dormant oils, again, are not primarily, are usually available for us as gardeners, and so we will use summer oils. And we can use those a couple of different ways. We can use those as a ready-to-use product, an RTU product, which are typically 1% to 2% oil and are made to be able to be sprayed directly on growing tissue, as well as concentrates, which are 98% oil, but these are what so-called summer oils, but they are now used for both summer and dormant purposes. And I've given you there kind of the broad dilution amounts for this particular horticultural oil. And again, you just need to read the label very carefully. You need to make sure that the horticultural oil is for the susceptible pests that you're trying to manage. The dilution will differ on whether it's being used in the summertime on green leafy tissue or in the dormant phase, when to use it, how often to use, when and where not to use. There are just lots of things that you need to know about horticultural oils before you use them, and all of that can be found on the label. The final oil we'll talk about are essential oils, and essential oils are just volatile concentrated extracts from plants, and these are widely available in the marketplace. But there are a couple of things to remember about essential oils. One is in 1996, the EPA established that there were certain ingredients that pose very minimum risk to users and the environment, and that they no longer required EPA approval to be marketed as either insecticides or as animal repellents. And many of those products are essential oils. And so I've just put the question here, efficacy question mark, because most essential oil products no longer require EPA approval or registration. Again, efficacy data can be very minimal for these. And so you'll find these in a variety of insecticides and repellents. And if you're going to use essential oils, I would focus on those where you're using the active ingredient. And one example of that is eugenol, which is found in clove oil, and it is a fast-acting contact insecticide. It's effective in a wide variety of household and garden pests. So if I was going to use an essential oil product, I would rely on that. So again, pesticide users beware. I think the efficacy around essential oils for many of their uses is oftentimes lacking. So let me stop there. We talked about insecticidal soaps. We talked about horticultural oils and essential oils. And let's see if you have any questions about those.
I'm not seeing anything at the moment, Phil. Oh, here we go. What about citrus oil?
Citrus oils, we will talk about one of those products here in just a moment. So hold on for that.
Okay, we're getting several questions about neem oils.
We'll talk about that next.
Okay, are essential oils cut with a carrier oil?
Yes, they can be. And that carrier product can vary widely from product to product.
Okay. And then one more, how would you mix up essential oil pesticides?
That's a good question. I don't have any recipes specifically for taking a very concentrated essential oil and making your own dilution. I primarily just want you to be aware of those products that are in the commercial marketplace.
Okay. And then you may get to this, but this is regarding application about how do we spray to control the bad pest and save the beneficials?
That is a very difficult question. Primarily, we're going to talk about some products that are, say, toxic to bees, so they should not be used on many plants when they're blooming and attracting pollinators. And again, using them early in the morning or in the evening when the beneficial insects probably aren't as active is probably the best general recommendation.
All right. And then in your talk, are you going to cover anything about controlling voles?
No voles today. So there is a video on the Buncombe County Master Gardener website about controlling voles and moles. So I would just point you to that video, and Allison, you might put that in the chat.
I'll do that. Thank you, Phil.
Okay. So we're going to move on to botanical as a general category. And the first one is pyrethrum. Pyrethrum is a general term for a group of compounds, about 5 or 6 different natural compounds that come from the Pyrethrum plant, which is in the chrysanthemum family. The flowers are grown commercially, they're harvested, dried, and then these natural compounds are extracted. A couple of things about the natural pyrethrum compounds. They're very quick acting. They're what we call knockdown products. And so you can actually spray that on an animal with fleas, or you can spray that on a plant with insects, and literally it will cause neurological problems, and they'll literally fall off and fall to the ground. And so they're very quick acting in that regard. However, they degrade very quickly, especially in sunshine, so they don't stay around for very long. But they do have very low toxicity for both the plants and for the environment and for animals. And because they are quick acting but don't really have residual effects, they're often mixed with other pesticides that might have longer acting activity. Now, in addition to, there are a group of synthetic chemicals called pyrethroids, and you're going to find a variety of those. There's probably at least 10 or 15 pyrethroid products on the commercial market. These are synthetic cohorts. They're much more toxic to the insect, but they're also much more toxic to beneficial insects and to animals. And they do persist longer on the plant, which makes them more attractive. And they do persist longer in the environment. But from a natural and organic standpoint, the only products that fall in that category are going to be the natural pyrethrums. Somebody asked about neem, and this can be a little bit problematic, so I'll kind of walk through this. These are basically an oil or extracts that come from the neem tree seeds. And they really fall into 3 categories: unrefined neem oil, clarified extracts of neem oil, and then one of the active ingredients in neem oil, which is called azadirachtin. There are several other compounds, but azadirachtin is the one that's been studied most, and it specifically is good as for insects and mites. It's an insect and mite feed deterrent. It appears to deter their egg laying. It's an insect growth regulator, or IGR, which will adversely affect the development of the insect, and will also have some repellent activities. There may be some activity of azadirachtin also against some fungal organisms, including powdery mildew. Now, the problem what we have in dealing with neem products is the clarified extracts have had most of the azadirachtin and many of the other active compounds removed. And unfortunately, that's the wide majority of the neem products on the market that are called neem oil. You need to specifically read the ingredient list, and if it says clarified extract, then it probably means that most of the azadirachtin, even though it says that it may have some insecticidal activity, that most of the active compounds have probably been removed. Unrefined neem oil, on the other hand, there are none of those products that are actually approved or registered for insecticidal activity. So the product that's shown here, Bless Pure Neem Oil, is an unrefined neem oil. You'd expect it to have azadirachtin and some of the other active ingredients, but it is primarily sold as a leaf polish. And so that's the problem that we have, is that most of the neem oil products are clarified extracts. They probably don't work very beneficially, and we may need to use a product like the shown here, Azamax, or something else that is specifically contains the azadirachtin. Somebody asked about citrus extracts, and this is one that's available commercially, is Limonene. It was originally marketed to veterinarians for tick and flea control back in the 1970s, and it's been on the horticultural market ever since as well. So it is a citrus peel extract and does have good efficacy against a variety of insects, and again, for tick and flea control as well. Capsaicin is the active ingredient in hot peppers. So those of us that like hot peppers and other hot vegetables, that's the compound. But it's interesting, this is a picture of Dr. Noelle McNicky when she was working on her PhD dissertation. I believe this is at Washington State. And this is the name of her thesis, How the Chili Got Its Spice. Ecological and evolutionary interactions between fungal fruit pathogens and wild chilies. And what she did her research in Mexico and in Central America, I think it's primarily southern Mexico. And what they had known for many years is that you could take the exact same variety of pepper and you could grow it in a warm, moist environment where the fungal pathogens and the insect pathogen level was much higher, and it would develop into a hot pepper. And we know that most of the capsaicin is found around the seeds and the membranes that house the seeds inside the pepper plant. So you could take the exact same pepper, put it in a cooler, dry environment where both the insect and fungal pathogen pressure was much lower, and the exact same pepper would basically be mild. It had very low levels of capsaicin. And so what her PhD dissertation showed is that the plant produces capsaicin as a direct response to pathogen pressure, primarily fungi and insects. And so they basically coat the seeds and coat the membranes inside with capsaicin, which will go ahead and inhibit fungal growth and inhibit insect growth. So how do we use that? Well, there are a number of hot pepper wax repellents, both for insects, and these probably can also be used to inhibit fungal pathogens if used as a preventive. And so again, kind of taking that understanding from the natural world and applying that to the garden. And the final botanical we'll talk about is corn gluten meal. Corn gluten meal is the high protein portion of the corn kernel. So if we take a kernel of corn and we extract the corn oil, and then we extract the corn starch, what's left behind is the embryo part of the seed, or the high protein part of the seed. And corn gluten meal is used for a couple of things. It can be used as a natural protein fertilizer, and generally it will be marketed with around 9% nitrogen. But the corn gluten meal also contains allelopathic properties, which are basically compounds in the seed that inhibit germination, especially of small weed seeds. And so it can be used as a pre-emergent weed control, or you can use it as a combination product, both as a pre-emergent weed control and as a natural fertilizer. So those are the botanicals. We talked about natural pyrethrum, talked a little bit about neem, limonene, capsaicin, and corn gluten meal. So let's stop there and see if you have any questions about those.
Phil, we have a question about clarified neem oil. Should it be used basically as a summer oil? And they said not a hot shot insecticide.
So it certainly can be used as a summer oil, or it can be used in the dormant stage as well. It's probably going to have activity very similar to the horticultural oils that we talked about earlier. So that's the way the clarified extracts, I kind of think of them as another version of a horticultural oil, and would kind of use them in that same mode.
Okay. Someone indicated that they used neem oil on beans, and later when they picked the beans, they broke out in a rash. Should they use it at all?
Ooh, good question. I'm not familiar with the skin toxicity of neem oil, but I would say that could be a problem, and certainly it could be a sensitizing agent, but that's something I'd have to look into.
Okay, there's that question about how late in the day to spray not to hurt beneficials.
Basically, when you see that insect activity is slowed down, so usually about dusk is when I've done that.
Okay, where would you get unclarified neem oil, and what alternative is effective on powdery mildew?
I have not used, the unclarified neem oil, you're going to find it. You may find it in garden stores. You can certainly find it online, primarily marketed as a leaf polish product. And I have not used it specifically for powdery mildew, so I don't have a lot of good experience with using it for that particular condition.
Yeah, okay. And probably the same thing about corn gluten as far as finding that.
Yeah, corn gluten meal is found in many garden stores, and again, maybe as a weed preventive, marketed as a weed preventive, maybe marketed as a lawn fertilizer.
Yeah, okay. And then one final one about slug deterrent.
We'll talk about one of those here in just a minute.
Okay, all right, great, thank you.
Using disease-resistant hybrid tomatoes is probably the best way to go if you've had lots of problems with either early or late. Commercial tomato producers will use a very aggressive preventive spray strategy where they're spraying either every week or every other week with a variety of both organic and synthetic compounds. So they're both very difficult. Early blight is a soil-borne disease, so you can help prevent that by going ahead and pruning the lower limbs or lower leaves and stems on the tomatoes so they don't touch the soil, using mulch, basically trying to prevent splash from the soil up onto the plants. Unfortunately, late blight is a airborne disease that comes to us every summer up from Florida, and that can be very difficult to manage.
Great, and I'll refer people to the video list that I put in earlier. Phil has a video on tomato problems, diseases, and pests, which he covers tomatoes to good extent. I'll put that in the chat box here again. Very quickly, could you talk more about Spinosad and the conserve product, and how often is it safe to use in terms of resistance development?
Certainly, Spinosad is toxic to bees and some other beneficials, so it really shouldn't be applied to plants in flower or ones that are attracting insects. I don't know much about the resistance and how much resistance has occurred, but it's probably been most commonly used in flea control products, and there may be some resistance that's developed in fleas, but I don't know about other insects. And from its use, again, just follow the label directions.
Okay, great. Thank you.
All right, we've got three kind of miscellaneous things that really didn't fit into any of the other categories. One is milk. I have not really used milk for pesticides, but it's really been extensively researched. Various forms of milk, raw milk, pasteurized, non-fat, cream, dried milk, various dilutions of fresh milk have been studied in the lab. They've been studied in greenhouses and in field studies, and they appear to be most effective in reducing transmission of viral leaf diseases. And most of the viral leaf diseases are oftentimes transmitted by insects. The insects are the vector to go from one plant to the next. And milk products may have some fungal activity against some fungal infections, including powdery mildew, primarily on things like cucumbers and melons. And it's poorly understood what is the active component in milk. It may be proteins, it may be the carbohydrate portions of the milk. And it's really not known if they have direct antiviral activity or if they really just simply deter insect vectors. But from a prevention standpoint, based on most of the research that I've seen, they recommend using a 20 to 30% solution of fresh milk. And again, it doesn't seem to make a difference in the studies on whether it's whole milk, low-fat milk, etc. Acetic acid, somebody talked earlier about poison ivy. Primarily want to use what's called horticultural vinegar. Horticultural vinegar usually has between 20 and 50% acetic acid versus household vinegar. Most household vinegar is around 5 to 8% acetic acid, which probably isn't high enough to be very effective. This is a situation where you actually want to use it on a warm, dry day where we have moderate to high temperatures. Spray it directly on the weed that you're concerned about, but you do need to handle it with care because it can be very irritating to the eyes and other mucous membranes. So you want to be sure to use personal protective equipment, especially around the eyes and skin if you're using it. And this is probably one of the best ways to use a natural organic product for something like poison ivy. You'll also find products that contain citric acid and caprylic or capric acid will also be found in garden stores. And then we mentioned citric acid in low or in high concentrations. Citric acid in low concentrations can actually be very, very beneficial, and use it as a bactericide or fungicide. You can see here that it's around a 3.4%, at least that's the solution or percentage that's found in this specific product. And it has two benefits. It will act as a contact bactericide and fungicide. It's also at lower concentrations will be absorbed into the plant. It's actually been found that those plants then will produce their own antimicrobial compounds that will help deter infection by pathogens of bacteria or fungi. So it's best used as a preventive and may have both contact and systemic effects and is safe on edible crops. And I'm not familiar with this specific product or used a lot of citric acid, but I think it might really have some things that can be beneficial for us in the garden. So pesticide failures, we really don't have time to talk about today. So what I would do is direct you to the Extension Garden Handbook. Again, there's the appendix on pesticides is very good. And same things, the signs, symptoms of phytotoxicity, which is basically plant damage from pesticides, is covered in the manual. And the plant injury factors are covered there as well. And so if you have any additional questions, we'll take some questions here at the end. But if you have any additional questions or need some help, the Garden Helpline is currently open Monday, Wednesday, and Friday through October. Or probably the easiest way is to contact using the email address buncommg@gmail.com. And you can submit your question. You can submit pictures of plants or plant issues or pests that you're having problems with. And that's a good way to submit questions as well. So let me stop there and see if there's any final questions. We covered a lot of material. Again, I refer you back to the notes, to some of the additional resources we talked about, and hopefully that will help you get started in the right direction. But stop here for any final questions.
Phil, someone asked about Milky Spore, wondering about efficacy of Milky Spore.
So efficacy of Milky Spore is primarily is most efficacious against Japanese beetle grubs. It may have some efficacy against other grubs, but if you know specifically that you have issues with Japanese beetles, that's probably where it's going to be most effective. It appears that it not only infects and kills the larva, but then additional spores are released into the soil. So if you don't have any grub problems, it's probably a waste of time, because the spores will just go ahead and go into the soil and will not be retained for long periods of time. So specifically for Japanese beetles, and make sure that you have a population of beetles that can be controlled.
Okay, someone actually asked about coffee grounds as a pesticide.
Good question. I don't know of any studies that have been done with that. I've certainly used coffee grounds and as a soil amendment directly, and then in compost. And certainly there might be compounds in coffee grounds that have some pesticide activity, but I don't know of any specific studies that have been done with coffee grounds.
Okay, great. Yeah, there are lots of kudos in the chat box for your presentation. There was a question about the appendices A and B in the Extension Gardener link handout, or in the Extension Gardener handbook. There are some appendices towards the end. If you go to that site, you will find those, and they're all listed there. And I'll do that really quickly here, just to make sure that they got covered. We want to thank you, Phil, so much for this incredibly thorough presentation this morning.
Probably more information than you wanted to know, but hopefully this will get people started in the right direction. So
Yeah.
thanks again to everybody for joining us.
Yeah, thank you, everybody. The link to the recording will be sent to you as soon as it's available in its rough form. Want to also let you know our next program is Saturday seminar, June 26th, Growing Vegetables in Containers. And then our Gardening in the Mountains, July 15th, Selecting Western North Carolina Natives and Nativars. So thank you so much for checking us out and joining us today. Thank you.